We're now going to talk about the properties of the elements and ways in which we can arrange elements based upon those properties. When we arrange those elements, we get something called the periodic table. And because we've arranged these elements in the periodic table according to various properties, we can actually pull information out from the periodic table that relates to those properties of the elements. Now, the basic idea around the periodic table is something called periodic law, which states that the properties of elements vary in a periodic way with their atomic numbers. Atomic numbers meaning the number of protons in their nuclei. When looking at a periodic table, you should be able to quickly extract information related to these topics listed here. The first one is going to be the atomic symbol. If we're looking at a periodic table, atomic symbol is going to be those bold letters that represent the elements. They're shorthand notation for the elements. So for example, H stands for hydrogen. He stands for helium. Those are the atomic symbols. And they're just quick ways of us writing down what these elements are. Now there's a lot of elements here. Majority of these, you're going to be able to recognize their symbols just because you're going to be using them so much. So don't worry about sitting down and memorizing out the periodic table and all the elements. You're going to see these often enough where you're eventually going to pick up and know and recognize a lot of these atomic symbols. Those that you don't, yeah, you may have to open up your book and look them up, but that book will be available. Next on the list, atomic number. Atomic number is going to be the number above the atomic symbol on the periodic table. The atomic number is going to tell us how many protons an atom of that particular element has in its nucleus. That's what the atomic number means. So for example, hydrogen, because it has a 1 above it, an atom of hydrogen has 1 proton in it. An atom of lithium, Li, right below it, has 3 protons in it. Next we have mass number. Mass number is going to tell us the number of protons plus the number of neutrons in a particular atom. We don't actually show the mass number on the periodic table. What we actually show on the periodic table is what's right below it, the atomic mass. And the difference between those is mass number relates actual numbers of protons and neutrons. Atomic mass relates the average mass of the isotopes of those particular elements. That atomic mass, when we look at the periodic table, is the number right below the atomic symbol. So once again, going back to hydrogen, hydrogen's atomic mass is 1.008. The reason why it's not exactly 1 is because hydrogen has multiple isotopes that occur in nature. Because of that, it looks at an average type mass. And you're going to see those isotope calculations later on in the chapter. Next, we're going to have periods, and we're going to have groups. The periods are going to be the rows on the periodic table. The groups are going to be the columns. Now between the two, the groups are probably going to be more important because the groups are going to help us identify elements that share similar properties. So elements in the same column are going to have similar properties to each other. The next thing we're going to talk about are metals. Now here we've got a couple of pictures of metals. We've got strontium, we've got a picture of copper. All the metals are going to be solids at room temperature except for mercury. Mercury is going to be a liquid. All the metals typically going to have a reflective surface, which means they're going to be shiny. They're typically going to conduct heat, and they're going to conduct electricity. Metals are also going to be malleable. Now what that means is they can be shaped. So we know that metals are used for a wide variety of things, but in order to make those things, they have to be able to shape them. Metals are also going to be ductile. What that means is they can be drawn or pulled into wires. Because they conduct electricity, because they can be drawn or pulled into wires, that's why we use a metal for all of our electrical cords. Metals are going to lose electrons and form cations in chemical reactions. That's going to be important, especially when we get into naming. Metals make up a huge portion of the known elements. About 75% of the known elements are metals. Typically, when we look at a periodic table, the metals are going to be on the left-hand side, and the most metallic is going to be on the lower left-hand of the periodic table. If we look at this version of the periodic table, we can see we've got kind of the tan color for metals, and you can see where those metals exist on the periodic table. They take up a major portion of the periodic table, and they're to the left-hand side of the periodic table. One thing to note is that bold line, that's kind of making a staircase over on the right-hand side of the periodic table. That's a good cutoff point of where the metals end. All right, next we're going to talk about nonmetals. So we've got a picture of sulfur, bromine, and chlorine. Nonmetals can be found at room temperature in all three states. Sulfur is a solid, bromine is a liquid, chlorine is a gas. They're going to be poor conductors of heat, as opposed to metals, which were good conductors of heat. They're going to be poor conductors of electricity. Those that are in solid form at room temperature are going to be very brittle. Nonmetals are going to gain electrons in reactions to form anions. On the periodic table, the nonmetals are going to be to the right, and kind of we say the upper right because it's the upper right of that bold line staircase that we saw before, except for hydrogen. Hydrogen is a nonmetal, even though it's technically on the left-hand side. Okay, so let's go back to our picture here. So nonmetals are represented by the green, and you can see where those are situated at. All right, let's talk about metalloids now. So with metalloids, they're going to have some properties of metals and some properties of nonmetals. So if we look at silicon, which is a very well-known metalloid, it's shiny. It actually conducts electricity, doesn't conduct heat well, and it's brittle. Shiny and conducts electricity, those are properties of metals. Doesn't conduct heat and is brittle, those are properties of nonmetals. So metalloids fall between metals and nonmetals, and a lot of times metalloids are also known as what we call semiconductors, or combinations of metalloids are what we know as the semiconductors that we use today. So if we go back to our table here, keep in mind that bold line forming that little staircase. Now you can look at the purple elements. You can see they fall between the metals and the nonmetals because their properties fall between the metals and the nonmetals. So with the metalloids, we can see number 5 is boron, number 14 is silicon, number 32 is germanium, number 33 is arsenic, number 51 is antimony, number 52 is tellurium, and number 85 is astatine. Those are the only metalloids on the periodic table. You're going to need to be able to identify metals, you're going to need to be able to identify nonmetals, and you're going to need to be able to identify the metalloids. So next on the list we have the alkali metals, the alkaline earth metals, the halogens, the noble gases, and the transition metals. So if we look at a periodic table, the alkali metals are going to be in group 1. The alkaline earth metals are going to be in group 2. The transition metals are going to be in that middle part of the periodic table. The noble gases are going to be on the far right of the periodic table. And the halogens are going to be just to the left of the noble gases. Now, even though these aren't on the list, they're still important in the periodic table. We have the lanthanides and then the actinides. So you need to be able to identify all of those given a periodic table. When looking at the periodic table, this is just a slightly different version. You can see that we've got group numbers, and when looking at the group numbers, starting from the left, it goes 1A, 2A, and then it jumps to 3B for the transition elements. So we make a distinction with these between the transition elements and the main group elements. So the main group elements get their own set of group numbers, and the transition elements get their own set of group numbers. That's important because when I talk about in terms of group 7, which is the halogens, I'm not referring to group 7b in the transition elements. Okay, it's a minor distinction, but you need to be able to recognize it. All right, and the last thing on the list, we've got our diatomic elements. If we look at the name diatomic, well, di means 2, and atomic is talking about the atoms of the elements. So these are going to be elements that exist in their natural state as 2 atoms of their element combined together. So for the diatomics are going to include hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. Now, one thing I use to help me remember how many diatomics there are and what they are, if you start at nitrogen and draw a line over to fluorine and then draw a line from fluorine down to iodine, it forms the number 7. That tells you there's 7 diatomic elements. So you have nitrogen, oxygen, fluorine, chlorine, bromine, iodide. Those are 6. And then you toss hydrogen in to get to your 7th. Okay? So that's one way I use to remember these things. So again, from the periodic table, you should be able to identify everything on this list. That periodic table contains a lot of information. So having a periodic table in front of you and be able to readily pull out that information is going to be important. The last bit of information that you can pull out from the periodic table are some basic monatomic ions of the elements. Okay, and there's some common patterns if you look at it here. Group 1, all of those form +1 cations. Group 2 form +2 cations. If you look at group 8, which would be the noble gases, you can see those don't form any ions. They're called noble gases because they really don't like to combine with anything else, so they really don't want to form ions. Group 7, which is the halogens, is going to form -1 anions. Now the rest of the elements in the periodic table, you can kind of see they're either blank or they have some ions there. These are fairly common ions, and you can remember those. Oxygen is typically a -2. Sulfur is typically a -2. However, those can vary a little bit. If you look in the transition metals, however, a lot of those you see there's more than one ion. So it's not important that you memorize all of those and be able to predict all of those ions based upon looking at the periodic table for the transition elements. We're going to find when we talk about naming that we're going to be able to predict those charges when we get around to naming compounds. Alright, so that's it for the periodic table. Keep in mind, you need to know all those things. You need to be able to recognize things off the periodic table. You'll always have a periodic table available. So the more information you can get used to pulling from it, the better off you're going to be.